Okay guys, because the weather's not cooperating, going to do a little training video on chilled water air handlers this week until I can get back up on the roof and finish my series on economizers on rooftop units. So just going to try to cover the basics in this video today. So if you're well versed in chilled water, I apologize for going over some basic stuff, but just want to make sure everyone's on the same page and has the same foundation going forward with this. So in a mall where there's chilled water and we have air handlers that we work on, the mall has the chiller in their mechanical room, their chiller room, their boiler room, their penthouse, whatever they call it. They are in control of the chiller. And depending on the mall, this is where these animals get complicated, guys. Don't let it scare you, but every mall is engineered differently. Some of the malls were built in the 60s, some in the 70s, 80s, 90s. Different mentalities, different technologies. Some of the malls in the 60s have been modified. So you got to pay attention, is what I'm trying to say. You have to get to know the mall engineer. You have to get to know how your mall functions, because they all operate based on what they want to do. It's their mall, their chiller, their equipment. So we are not in control of that, but you have to understand what they are trying to accomplish. Otherwise you'll never know what your unit and your store should be or shouldn't be doing. You really have to understand the whole system, is what I'm trying to say. So mall has a chiller. Malls, especially nowadays with the economy and energy savings, guys, they don't want to run this chiller unless they have to. So a lot of them do it based on outdoor air temperature. Once the outdoor air temperature is above 55, 60, 65, 70, every mall is different. The mall decides that when they will turn the chiller on. So let's assume it's summertime, they're running the chiller. Some malls have pumps. Most malls have pumps in their mechanical room to recirculate the water from the chiller through the pumps up to the stores, through the whole piping system, and water just flows in a big circle, everyone. The water just goes out cold, picks up heat from air handlers, comes back to the chiller warm, gets cooled back off again, and just, that's all it does, is goes around and around all day long. Some malls, I've seen this in the Chicago and Wisconsin area a lot, they have minimal pumps in their mechanical rooms, and they actually have pumps. Every store has its own pump on the air handler. So by doing that, the store picks up the electric bill for moving the water through the system for the mall. It saves the mall a ton of money. It also moves the maintenance of said pump to the customer, which means it moves that maintenance of that pump to us as technicians for MetroTech. So keep that in mind. Just every mall is a little bit different. Every mall has different logic and different ways of running their plant. So you need to know what they're trying to accomplish before you start taking steps to fix or repair or change things. You have to work within what they are doing, within their operation logic. So, basics. Chiller, pumps, sometimes in the mall's plant, sometimes in the mall's plant and the store, sometimes just in the store and not in the mall's plant. Again, you got to ask questions. Basic logic or basic terminology I want to talk about a little bit, guys, is water or glycol. You need to pay attention to that. Again, this is the mall's decision, not yours, not mine, not ours. The other thing you need to pay attention to is do they have a boiler and a chiller, or do they have just a chiller? If they have a boiler and a chiller, they might have a 4-pipe system where they have a chilled water supply pipe, a hot water supply pipe, a chilled water return pipe, and a hot water return pipe to the boiler. That is what we would typically call a 4-pipe system. Or they might just have a two-pipe system. Let's say they just have a chiller. Again, every mall's different. One pipe going out and water supply into a coil on an air handler, and one pipe coming out, water return. That's a two-pipe system. Now this is where it gets a little bit complex. Again, depends on the mall. Some malls have two pipes, one supply, one return, but down in the plant, they tie these two together with valving, and in the winter, they heat the water in this loop. In the summer, they chill the water in this loop. So it's a two-pipe, but it's hot water in the winter and chilled water in the summer. That two-pipe system with a boiler is, you really got to pay attention, because the air handler needs to know if it's calling for air conditioning, but the mall is running the boiler. You don't want to open an actuator and run hot water through the coil. There's a lot of extra controls added to make sure that so that the unit knows if it's running chilled water or hot water, and what to select, when to open the valve, when not to. So it gets a little bit complicated there, but pay attention to what the mall has before you start messing with controls. If you don't know what is in the pipe, or if it's chilled water, hot water, or a combination, then don't start changing controls and wiring until you understand the system, is what I'm trying to get at. So again, mall controls this and this. Mall also decides if there's water in the pipe, or water mixed with antifreeze, aka glycol, what percentage, what it's rated to for freezing. Based on this, guys, is also where the mall decides whether we're draining coils in the wintertime or not. Some malls have glycol. They run their recirc pumps in the wintertime on their chilled water when it gets below freezing, so that the water is circulating and they don't freeze up. That is their decision. You have to understand what they want and what they're doing before you piss them off. Work with them, don't work against them. Understand the logic is what I'm trying to get to. Talk to the mall guy, talk to the mall guy, talk to the mall guy. And just get to learn them all. So, I wanted to show again, just basics. Piping. This is representative of an air handler of a 4-pipe system. Chilled water coil and a hot water coil in the same unit. Chilled water piping and hot water piping. Hopefully some of you have noticed, this is something I see a lot in the field. I've seen over the years mistakes are made because people don't know, installers, but it's up to us to find the stuff and see it when we start working on the unit. You'll notice that I've got the supply pipe on the bottom of both of these coils. Most of you have already figured out why, or already know why, but if you ran water into this coil on the top and come out the bottom, you would never fill this coil 100% with water. It would trickle down. You'd have air pockets within the tubes in there. You'd never guarantee that that coil was 100% saturated inside the tubes with liquid and not liquid mixed with air. If you run the water in the bottom, it fills the coil and pushes the air out. You will always be 100% full of water in the coil. If you're 100% full of water, you've got better heat transfer. It's just basic thermodynamics, everyone. The other thing you'll notice here is that typically, depends on the mall again, some guys do it differently. Typically, your valve, your control valve for your hot water or chilled water is on the return pipe coming out of the unit, not on the supply pipe. For the same reason I just talked about, you want this coil full of water all the time. When the call for cooling ends, this valve shuts, this coil is 100% full of water. There's no air in it. When the call for cooling comes on, it just simply allows the water to start flowing again through the coil. So pay attention to that. The other thing I want to show you here is that in a 4-pipe system, and I've seen this done incorrectly multiple times, is if you take a close look at one, if you have a 4-pipe, the hot water coil is, if we assume airflow coming from the bottom here, Airflow comes in, will always come to the hot water coil first. So through the air filters to the hot water coil, through the hot water coil, and then to the chilled water coil, then to the blower and the discharge duct going out of the unit. Reason for that is two things. Main thing is the hot water coil protects the chilled water coil. It's part of the freeze protection logic. There's heat in front of the cold water coil from the economizer, or the cold air coming in from outside if something goes wrong. The other thing you'll notice if you look at them close, guys, is notice how I've got lines on the hot water coil and there's much more lines on the chilled water coil. If you look closely at a 4-pipe system, hot water coil in front of a chilled water coil, the space between the fins on the coils on the hot water coil are wider on the hot water coil to allow the airflow to get through and get to the chilled water coil, so it doesn't restrict the airflow. So if you put chilled water in this coil, if someone pipes it backwards and you've got chilled water going into this coil, number one, you don't have as much contact time, so you won't cool as well. So if you have a cooling problem in a store that you've never been able to figure out, you could be piped backwards. You could have the chilled water going through the hot water coil. It's not designed for that. The other thing you have to pay attention to is because there's a bigger gap here, the air goes past this coil. This coil doesn't get dirty. So you might look in here and say, hey, these coils are clean, I don't need to wash them. All the dirt's going to be sitting packed onto this coil. So you have to open up sheet metal. You might have to cut a hole, remove panels. You've got to look at and clean the space. You know, if you had these two coils sitting like this, you can get in there and see that. A lot of times I see that second coil, just like a condenser coil when you got to split and wash them. This coil will have all the crap on it. And that will kill your airflow, kill your cooling, obviously. So enough on that. Quickly while I'm here, most malls nowadays have a 3-way valve for the valve instead of a 2-way valve. They do that so that there's always water going back to the plant, the cooling plant or the chilled water plant. You need to pay attention to that because that changes the logic of the unit. The other thing I wanted to note while I'm here is you'll notice that on the hot water coil, notice how I have, that doesn't say no, that says NO for normally open. If it's set up properly, guys, if you have a 4-pipe system, the hot water coil, the actuator and the valve for it these should both be spring return actuators. So in a power failure or a alarm state, when you kill power to the unit, this hot water valve opens and allows hot water to flow through the coil. That quickly warms the coil, quickly warms the inside of the unit, and it's a part of the freeze protection. You don't want to have both of these coils the same, or both of these valves the same logic. You want this hot water valve to be a normally open valve. You want this valve to be a normally closed valve. Spring return. You kill the power to the unit. This valve shuts off the chilled water. This valve opens, allows hot water, if there is any, to go through the coil so it doesn't freeze. What else do I have here? 2-pipe system, like I was just talking about. Here's a coil. Water heated in the wintertime, water cooled in the summertime. You use the same actuator. These get a little bit complicated, so again, pay attention to what you have. You have to know what the mall is sending you before you can start working on one of these. You have to understand the difference. There's 2-pipe systems where you have chilled water only, and you have auxiliary heat, which would be electric strip heat most of the time. Can be inline gas heat, can be an auxiliary coil that was added 10 years after the mall was built. Pay attention to what you have. You're going to have to do some digging. You know, open up panels, look around, and see what you got. So the next part of this I want to move on to is, again, I'm going to try to just cover the basics today, guys. I might have to adjust my camera here a little bit, so bear with me. Let me move in here a little. Basic chilled water air handler is, just think of it as a rooftop unit. It has an economizer on it. because when the mall shuts off the chiller, the only means of cooling this store has is the outdoor air. So when it's 40 degrees outside, the mall shuts off the chiller because they're trying to save money. They know that the store has free cooling, outdoor air, Economizer. So these stores, the Economizer has to work. It's not an option. You don't bypass them. You don't, cuss and swear at them. You got to make them work. It's the only cooling they have for my part of the country 6 months out of the year. So a couple things I wanted to show you here is, so we've done some Economizer training so that these don't scare you. This is just, instead of having an evaporator coil inside of this unit, we've just got a chilled water coil and a hot water coil. Again, you'll notice water in at the bottom so that we fill the coil 100% with water before the chilled water comes out. Same with the hot water. We control it basically the same way. We have an Enthalpy sensor for outdoor air temp. This is the little dotted line here, guys, is the roof. Assume that that's the roof above the store. This is the intake for the fresh air from outside. Enthalpy sensor here, so it senses the outdoor air temp. Draws air down through this set of dampers with an actuator on it for outdoor air, and then it's mixing with the indoor air from the store. Pay close attention, guys, to this actuator for outdoor air. These actuators both need to be spring return actuators as well. This one for outdoor air needs to be normally closed. So when you shut off the power to the unit, the spring in the actuator will cause these dampers to close in a power outage. That's how you know you've got it set up right for logic. At the same time, this actuator for indoor air, when you kill the power, the spring in that actuator will cause these dampers to open. So they're open 100%. Now here's something to pay attention to because you have linkage issues and sometimes you can't get the dampers to go 100% open and 100% closed. This damper here, you want to make sure this damper is 100% shut. That you're more concerned about it being shut all the way than getting it open all the way for freeze protection. This damper here, same thing. You want to make sure it goes 100% closed when it's driven open, because when you're economizing, let's say it's 60 degrees outside, you're drawing in 60 degree air, trying to get to 55 degree air, discharge air temp over here. You want to make sure that if you're leaking a little bit of 80 degree air from the store into here, it's going to kill your discharge temp. You want to make sure these shut all the way and these shut all the way. So make sure the dampers close all the way. Don't be as concerned about them opening. You need to be concerned, but if you only have one option or the other, make sure they close all the way. One thing I want to mention while I'm here is just basic positioning. You can see that this is the mixed air temperature sensor. These are the filters, or what I tried to draw as filters. So this is measuring the mixed air temp after the two dampers. Once we're mixed, we're trying to get to 55 degrees here, everyone. The freeze stat needs to go in front of the coils. I see guys that put it after the coils. If you put a freeze stat here, and you have either electric heat in here, electric heat here, or a hot water coil, and the heat is stuck on for some reason, it will never trip the freeze stat, and you could have 20 below air at this point, freezing up your coils. So the freeze stat goes in front of both the coils. It's the only place it can go. The other thing I wanted to mention here, and again, I'm going to try to keep this video short, guys, so this is just basics on this, but something, because it's that time of year on chilled water air handlers. I've seen it several times where you go out, or a guy has gone out, we've been out several times on a chilled water air handler for a water leak, and the drain is clear, it's got a good drain trap on it, and no one can figure out where the water is coming from. If this coil is plugged, or even if it only has one coil, but like I said, the area between where it's kind of a blind spot, this coil is plugged with dirt. The blower is running, sucking air, and the blower doesn't care. Air doesn't care. I'll take that from a friend of mine. I like that saying. Air doesn't care where it's going. This blower is trying to suck as much air as it can. It's trying to suck air through any little opening in this coil. it will suck air around the bottom of the coil through the drain pan. And if the drain pan is full of water, it'll start sucking water out of the drain pan. It'll cause this box to fill up with water. You'll get a water leak, and no one can figure out where the water is leaking from. If you've got a water leak on an air handler, check the coil. 9 times out of 10, the coil's plugged and it's causing the water leak. It'll happen on a rooftop unit, guys, but not as often because of the design of rooftop units. It happens, more often on these units where it gets missed because of the simple fact that the coil is compacted. So, with that said, I'll go into controls more in the next couple of videos. I'm just trying to cover the basics in this one, everyone. It's just a basic box with a blower sucking air through it. You have a mixed air temp or discharge air temp. I sometimes like to use my mixed air temperature sensor instead of here. I like to put mine here. I'll explain that later at some date. But never a freeze stat here, guys, just so we all understand. Never a freeze stat here. Pay attention to the dampers. The other thing that gets a little complicated on these, and I'll talk about later, is you see here on this one I've got smoke exhaust. On some malls, the mall is tied in to the unit partially in a fire mode. This blower will come on when there's a fire. It'll shut these dampers and shut these dampers. Sometimes it'll have an extra set of dampers here possibly, and they'll actually use this blower to, this is from the store, they'll suck smoke out of the store and blow it up on the roof. Some stores utilize this, see this in Chicago a lot, where this is a smoke exhaust for the mall, but the store uses it for power exhaust when it's economizing. So when we're taking 100% outside air, these dampers are closed, this blower comes on and it sucks the hot air out of the store. It helps to make the economizing or free cooling more effective. You're pulling in cool air, sucking out the hot air. It helps to cool the store off. So, hope that helps everyone. Again, just the basics wanted to talk about. 2-pipe system, 4-pipe system, water, glycol, actuator is the little motor that drives the dampers, or the little motor that drives the water valve on a unit. Again, you need to pay attention to the mall guy, understand what the mall does, when the mall runs their chiller, when they don't, and just get familiar with the mall. Don't be afraid to go and talk to the mall guy. So hope that helps everyone. You guys all have a great day.